Hello, my lovely students. So we are now back to 2A-3 multiplication and division of fractions, which might actually be two different things in Alex. We shall see. But it is one set of notes for us that I'll split into two videos more than likely. All right. So another week, another topic. Multiplying fractions, and we've hinted at this a little before, but here's our formal definition. To multiply fractions, write the product of the numerators over the product of the denominators. Yeah, that's fancy. Then simplify the resulting fraction. Because from here to the end of math, if you have a fraction, make sure it's reduced. Whether you leave it improper or mixed, if it's not a word problem, leave it however you want. If it is a word problem, the mixed numeral will probably make more sense. Okay, so if my first fraction is a over b, and my second fraction is c over d, then I multiply the numerators, the tops, and I multiply the bottoms, and I just make that my new big fraction. Now this works the other way as well. I can take a times c on top, split it to two different fractions, and then split b times d to the two different fractions. I could also write this a over d times c over b. That would be equivalent to a over b times c over d. So the problem may set the fractions in a particular way, but you can kind of regroup it if that helps with simplifying any. And sometimes it does. Other times, no. But, that's okay. All right. Multiply the fractions and simplify to the lowest terms. Write the answer as an improper fraction when necessary. So that's a fancy way of saying don't bother converting to mixed here. Leave it as improper. Why? Because it's easier to grade. All right, so 2/3 times 4/9. Now, sometimes in a word problem in particular, we will use the word of to indicate multiplying something. So like I might say, what's half of 100? Like that is the English way I would ask that question. And we know half of 100 is 50. Because 100 divided by 2 is 50. That's how some people would justify that. What I would say is when we say half of 100, we are saying what is 1/2 times 100? And that is 50. So whenever you're trying to translate like what you're being told, a lot of times there's certain words that translate to particular operations in mathematics. Now, sometimes the sentence will get written kind of backwards. So you might have to change the order the numbers appear in to get the problem to work with what you're being told. But just, a word to keep out for. I'll write that example here. Half of 100. 1/2 times 100 equals 50. So 2/3 times 4/9, or 2/3 of 4/9. Multiply the tops, multiply the bottoms. So 2 times 4 is 8. 3 times 9 is 27. There we go. Now 2 -11/5 times -3/4. Now I know these are negatives because there are not numbers in front of the minus sign to make this then a difference. If it was 1 -11/5 times 2 -3/4, we would have to do something different. We'd have to deal with that addition, or in this case, subtraction, before we could do the multiplication. Or you just type the whole thing really carefully on the calculator, answer. But for this one, so the first thing to consider is negative times negative. So a number of ways to remember this, but when you are multiplying, two negatives cancel out and it goes back to a positive. So every pair of negatives multiplies to a positive. So if you only have one negative and it doesn't get a partner to go with it, it stays negative. But if it gets a partner, ta-da, they can become happy, positive. All right, so This will be positive. 11 times 3 is 33. And on the bottom, 5 times 4 is 20. So there's our improper fraction answer, 33 over 20. But since one of our original starting 2 is improper, not a surprise our result is. It may be, it may not be. All right, 3. 12 times negative 1/7, or negative 1/7 of 12. Because usually we put the fraction first when we're going to use of like that. But we could also think of it as 12 of negative 1/7, or 12 copies of negative 1/7. Now, if we're going to multiply these from a purely mathematical, follow what the definition is telling us to do, we need a numerator and a denominator. So what can I divide 12 by and still have the result be 12? So 12 divided by what number is the same as 12 still? And it's not 0. We don't divide by nothing. I can't split something into no groups. So 1 is the number that we can always throw back in there if we need a denominator. So I have 12 over 1 times negative 1 over 7. So positive times negative doesn't have a partner, so it is still sad negative. But the top, 12 times 1 is 12. The bottom, 1 times 7 is 7. So I like to think of the sign of the product different from the numbers. So I'm not saying that negative 1 goes with the 1 and goes with the 7 in the 1/7. You could assign it to just the top or just the bottom if you want. You have to be very careful about it only goes to one of them. Because negative 1 over negative 7 is not the same as negative 1/7. All right, now a little bit uglier. These now can be simplified. Hopefully you're looking at these and kind of thinking, wait. 14 and 21 got something in common. They do. And 21 and 15 have something in common. So instead of multiplying first and then simplifying, which does work, it is not wrong. It's just the numbers get big pretty quickly. Instead, we could simplify the fractions and then just figure out what the final fraction would be after we cancel out the common elements. So I can still multiply them together. I'm just not actually going to figure out, well, 2 21s isn't bad, but I don't want to know what 14 15s are. I just don't. Yeah, it's only 210. No, it's not. Ugh, I always mess up my 15. Nah, doesn't matter because I don't actually care what it is. What I do care about, positive times negative, this will be negative. That is a horrible negative sign. Negative. And then on top, I have 2 times 21. So what I'm going to do instead is I'm going to change 21 to a factorization. In this case, I know 21 is 3 times 7. Then I'm going to do the same thing on the bottom. The bottom is 14 times 15. But rather than multiplying that out, I am just going to change it down to the prime factorization. 14 is 2 times 7. 15 is 3 times 5. We got a whole lot of cancellation going on. So 2 on top, 2 on the bottom, divides to a 1. 7 on top, 7 on the bottom, divides to a 1. 3 on top, 3 on the bottom, divides to a 1. So what is our number left over on top of the fraction? Whatever they divided to. So this result is negative 1/5. As long as you're careful about typing this in using your parentheses, some calculators will get very picky about, did you type the negative sign or did you type the subtraction? Like some calculators, those are different buttons, and if you type the wrong one, it gets mad. So on some of the calculators, if there is a button that has the minus sign with some parentheses around it, that's the negative sign and what you would use to type this in. And then the button with just the dash, will be subtraction. And then this button is usually located with the plus, the minus, the times, and the division symbols, whereas this negative, at least on a Casio calculator, is somewhere hiding up top. On a TI, it's down by the decimal. But likewise, you can't use negative in place of subtract. It does not work. If I wanted to know what 1 minus 3 was, I have to use 1, subtract 3. If I do 1, negative 3, I'll probably get a syntax error. Otherwise, it'll try to multiply them. So calculators are wonderful tools, but they are still tools. You can use them badly. I can take a screwdriver, turn it around, and make it a very bad hammer. You shouldn't do that. It's bad for the screwdriver, but you could. All right, number 5 here. 5 copies of negative 2/20. Well, this is going to reduce a lot for us. So these numbers are smaller. It's not 14 times 15, 2 times 21. Those are bigger things that I'd probably have to calculate by hand. But the 5 on top and then the invisible 1 on the bottom, I can go ahead and multiply those. They're not that bad. Or I could cancel them now if I happen to notice some stuff that would reduce. Either direction works. There is not a, you must do it in this order here. You must do it in a way that is mathematically correct and makes sense to you, that you can consistently apply. So here, if I multiply 5 times 2, well, positive times negative is negative. 5 times 2 on top is 10. And 1 times 20 on the bottom is 20. Oh, see, that's nice. Those are both multiples of 10, which means I can divide them both by 10. So on top, 10 divided by 10 is not 0, it's 1. Still negative. So negative 1 over 20 divided by 10 is 2. There are 2 10s and 20. So there's our result for number 5, negative 1/2. Now, negative 28/16 of 8/49. Why? Because they could. Again, negative answer. Let's go ahead and flip colors. All right, 28, that is 4 times 7. I could break the 4 down more, but the only thing it could interact with this is 16, and it could, but I also have that 8 on top that is likely going to interact more with the 16. Okay, so this 7 on top is going to cancel one of the 7s on the bottom. We're very grateful for that. Now, the 8 on top, if I divide the top and the bottom by 8, one of the numbers in there, divide by 8. So in this case, if I do 8 divided by 8, this becomes 1. If I do 16 divided by 8, this becomes 2. So now I have 4 over 2 times 7, but wait. The 4 and the 2 can be reduced more. So I can divide that by 2 and divide the 4 by 2, turning this into 2 and then this into 1. The only thing left on the bottom is a 7. The only thing left on top is a 2. So our final result is negative 2/7. See, not too bad. Just got to put them together and simplify. All right, now we have some letters. These you cannot easily type on most calculators. If you try to type the letters in there, and you can, there are letters in there, the letters have a default value of 0 unless you set them to something else. So if you try to type these with the letters, it won't work. It's just going to give you 0, or it'll give you error, divide by 0, but it won't actually help you figure out what is going to cancel from the variables, the letters side. You can strip the letters out and do all the numbers in the calculator, and then you just have to figure out the variables on your own. But they do function as numbers. So if instead of M, I had the ugly 17, I'd have 4 times 17 on top, and I have 2 times 17 on the bottom. So the 17s would cancel, which means the m's here will cancel. And then the 4 on top and the 2 on the bottom, those can also reduce some. So same kind of thing. Get rid of the elements that are in common. So I'm going to zoom in a little here. M on top, M on the bottom. Then the 2 on the bottom, I divide 2 into 4 and get 2. Then I divide 5 into 25 and get 5. Leaves 1s left over in the other spots. So 2 times 1 is 2. 5 times 1 is 5. Yeah. All right, now the book's kicking it up a notch. Like, oh, you getting cocky. Well, yeah, I am, but I'm a math geek. All right, see how we can handle this. Sign first because there is one. Positive times negative. Our final result is going to have that negative in front of it. Now our variables, I've got an x and an x, a y and a y, all of which cancel. So our final result will have no variables, just like our previous question. All the variables canceled. Here, all the variables cancel. So now we just have to consider the numbers up here. So 33 and 22 hopefully look a little familiar. 33 is 3 times 11. So another way to kind of think about writing these, sometimes I'll do it like this, is I'll cross out what I had, and then I'll write next to it what it is instead. So this way I actually have my 11s that I can see and I can cancel. So I have a 3 on top and a 2 on the bottom. All right, now we want to consider that 36 and that 48. There are a number of numbers that will divide in there, but the biggest one, 36 is 3 dozen, 48 is 4 dozen, a dozen is 12. So 36 is 3 times 12, 48 is 4 times 12. So now 12 on top, 12 on the bottom cancel. So on the top, I'm left with 3 and 3, on the bottom 4 and 2. So this gives us an end result of negative 9/8. And again, if you crunch just the numbers, totally strip out the variables, you can get that same result. 9, we're actually going to have some variables in our final answer finally. So positive times negative, our result will be negative. Then I have a b squared on the bottom and a b on top. So b squared is the same as b times b. A cubed on top here is the same as a times a times a. And a squared is just a times a. Now I like doing this because then you can more clearly see this single b on top with this single b on the bottom, and they cancel out. A on the bottom and a on top, gone. A on top, a on the bottom, gone. It can be any top and any bottom as long as it's one over the other. So our final answer is going to have an A on top. Now we just got to crunch the number parts. All right, so 14, there's only one way to write that really. That is 2 times 7. And 35 up here is 5 times 7. Then on the bottom here, 15 is 5 times 3. And 18 up here is 2 times 9, or 9 is the same as 3 times 3. So I'm going to write that. 2 times 3 times 3. And now again, we just cancel the stuff in common. I see a 5. Bam, I see a 7. Ooh, I don't like 7s. But I also see a 3 and a 2. So the only thing left is 3. And the A and the negative. And everything on the bottom canceled out. So technically the bottom is a 1, which means we can just write this as negative 3A. All that work for one little answer. That happens quite frequently in math. Mathematicians consider this usually aesthetically pleasing. It looks nice to have it simplify to a nice answer, a pretty single answer instead of the ugly fractions we started with. All right, the next one I'm going to talk about reciprocals and division.